13.1 exercise. This is exercise 13.1 conditional probability. So the method I told you. Now E and F are the events here already. Probability of event A, probability of event F is given, and intersection is also given. So find the probability of the event E when F has occurred. F has occurred, so that you know that probability of E intersection F divided by probability of F. So probability of E intersection F is 0.2 and probability of F is 0.3. Point and point will cancel 2 by 3 answer. Okay. Similarly, probability of F when E has already occurred is equal to probability of E intersection F divided by probability of E. Intersection F is 0.2, probability of event E is given 0.6. So 2 by 6. So if the values are given, we can easily find out. In second question, probability of same B and A intersection B is given. We can substitute in the formula, we can do it. So when the values are given, we can easily find out probability of probability of A intersection B, probability of A when B has happened, probability of A union B. These are the probabilities that we have to find out here. So in question number, I think we take question number 3. Question number 3, probability of A intersection B. First, we have to find probability of A intersection B and probability of B when A has happened. This is given, so we will go to apply this formula. Probability of A intersection B divided by probability of A. So probability of B by A is 0.5 and probability of A intersection B we have to find out. And probability of A is 0.8. So therefore the probability of A intersection B will be equal to the product of 0.5 into 0.8. So 8 for the 32, so 0.32. First part. Second part is simple as we have done question number 1. Probability of A when B has already occurred. So probability of A intersection B is just we calculated 0.32 divided by probability of B, that is 0.5 probability of B. Question number 3 we are doing this question. Okay, so that will be equal to 0.64. And the last one, that how to do that last one. Now we have to find probability of A union B. And A union B, from the relation that we studied class 11, probability of A union B is equal to probability of A plus probability of B. Obviously they are not independent events, conditional probability we are doing, so we have minus probability of A intersection B, that is given also here, value of A intersection B. So we can find by using this formula. Probability of A is 0.8, probability of B is 0.5, and probability of A intersection B is 0.32. So this will 98. So these are the questions where all the values are given. You have to apply the formulas. question number 4, question number 5. Okay, so I think I should go ahead for question number 6. You can ask, a coin is tossed 3 times where E head on. Now what we have to find? Probability of F has happened. Find the probability of E when F has happened from all these questions. Okay, so E is the probability on third toss, head on third toss. F is the heads on first 2 tosses. Okay, so as I told you, how to proceed these type of conditional probability questions. First, you have to write the sample space. Okay, so a coin is tossed 3 times. So 3 times when the coin is tossed means 2 raised to power 3. Total number of possible outcomes in sample space will be 2 raised to power 3 because 3 coins, 2 to the 4, 2 to the 8. So there will be 8 possible outcomes. So you can write head on the third, head on the first 2 tosses that we will find out afterwards. First, we have to write all the possible outcomes. So head, head, head. Okay. First, we will write head, 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 and do not write comma between them, because this is the first event where head, head, head can occur. Second event, we are taking tail, tail, tail. Now one head, 2 tails. How many times it can be occurred? Head can come in the first position. Head can come in the second position. And head can come in the third position. Tail, tail, head. Okay, one head. Now if you will take 2 heads, so 2 heads, first head, second head, tail, then head, tail, head, tail can come in between and tail can come in the starting. Tail, head, head. Tail, head, 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 tail, head. 1, 2, 3, 4, 5, 6, 7, 8. So you can see this. These are the all possible outcomes. Okay. Then you will write E and F. You can write F first. F is the event which is already occurred. So F is the heads on first 2 tosses. So first 2 tosses in which head occurs. First 2 tosses. Third toss can be anything. So first 2 tosses head occurred in head, head, head. Then this one head, head, tail. That's all. In first 2 tosses head occurred in this way. Okay. So you can find the probability of, okay, before that write the event E also. Head on the third toss. Third toss, head. Third toss will have head. No, not this one. This is third toss tail. This one. First one is also come here. Third toss will have head. This will come. Then this will come. Third tail, tail, head. Then this will also come. Head, tail, head. Then this will also come. Tail, head, head. Okay. So we got the number of outcomes in F2 and number of outcomes in E, favorable outcomes in E are 4. Okay, and total number of possible outcomes are 8. So NS here, NS is equal to, you can say here, NS is equal to 8. Number of favorable outcomes to event F is 2. Number of favorable outcomes to event E is 4. But we have to write one more thing, that is E intersection F. Event E intersection F is only one, that is head, head, head. Okay, you can see the red one and black one tick, both are only head, head, head. So the common between E and F, the common is head, head, head. Okay, so number of favorable outcomes to E intersection F is only 1. Now we have to find the probability of the event. So we can find separately first probability of E intersection F, because we need the probability of E intersection F and probability of F. So E intersection F is number of outcomes in E intersection F, number of outcomes favorable to E intersection F upon total number of possible outcomes. So that is 1 by 8. Okay. Then we have to find the probability of event F also, which is already occurred. So number of favorable outcomes to F upon total number of possible outcomes. So favorable outcomes to F is 2 and total is 8. So 2 by 8. Now we can find the probability of E when F has already occurred. The probability of, that means the formula is probability of E intersection F divided by probability of F. And probability of E intersection F is 1 by 8 and this one is 2 by 8. So 8 will cancel. We get the answer 1 by 2. Question number 7. It is simple. 2 coins are tossed once. So this is an experiment. So therefore the sample space will be 2 coins are tossed. So it can be head, head, and tail, head. E, tail appears on one coin. Event E, tail appears on one coin means only one coin. That means head, tail. And tail, head. Represented by event E. F, one coin shows head. One coin shows head means same head, tail, and tail, head. So both will have the same. Intersection will be same also. E intersection F is equal to also same head, tail, tail, head. So here obviously answer should come 1 because E is equal to F. I told you that probability of an event A has already occurred is equal to 1 and here E is equal to F. Here E is equal to F. Therefore they are same. Therefore probability of, we have to find the probability of E when F has occurred. The probability of E F has occurred will come 1. This we can say that on the basis of this property, you can say the answer will come 1, obviously. So we have to find the probability of E intersection F first. E intersection F is number of favorable cases of E intersection F, and E intersection F is equal to 2. Number of cases favorable to F is 2. Number of favorable cases to event E is also 2. Total number of cases and S, total possible cases are 4. So probability for E intersection F 2 by 4, and then probability of F is 2, again 2 by 4. So probability of E when F has already occurred is equal to probability of E intersection F divided by probability of F. So 2 by 4 upon 2 by 4 is equal to 1. Okay. Same question, no tails appears, no head appears. Okay, so no tail appears, no tail. So no tail means only head. E will be equal to no tail means only head. And no head appears, so F will be only tail. But they don't have any intersection. E intersection F is equal to null set. So therefore 0 upon something. So therefore probability of E when F has occurred will be equal to 0 upon something 4. That will be equal to 0. A die is thrown 3 times, 4 appears on the third toss, 6 and 5 appears respectively on first and 2 tosses. Same question number 8. A die is thrown 3 times. So sample space, you can write the sample space will have 3 times the number of possible cases, 2 raised to power 3, that is 8. And 4 appears on the, die. A die is thrown 3 times. Oh, yes. So 3 times it will be a very, very big sample space, but you have to write 1, 1, 4. And like this, you have to write all possible outcomes. That will be 3 dice are thrown. So 6 into 6 into 6. NS will be 6 raised to power 3. 6 into 6 into 6, 216. Sample space writing is difficult. Event appears on third toss, we can write this third toss. 4 appears on third toss. So this will be also a big sample space. So how we will write 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. If we will write like this 1, 1, 4, because 4 should come, we can write easily 1, 1, 1, 2, 4, 1, 3, 4, 1, 6, 4. Okay. Similarly here 214 to 264. Okay, got it? Array 264. Like this 314 to 364, 414 to 464, 514 to 2564 and 614 to 664. These are the outcomes where the 4 is coming on the third toss. 6 and 5 appears respectively on the first two tosses. 6 and 5, F is the event where 6 and 5 appears on the first two tosses, means 6, 5, 5, 6. Okay. So if 6, 5 is coming, 6, 5 can come with 1, 2, 3, 4, 5, 6. 6, 5, 6, 5, 6, 5. Okay. 6 and 5 appears on first two tosses. So 6, 5, 1 means first 6 and second 5. 6, 5, 1, 6, 5, 2, 6, 5, 3. Like this, it will go up to 6, 5, 6. So only 6 possible cases. It will have 6 possible cases. So therefore, number of possible cases in E, favorable cases in E is 6, 6 is 36. Again 36. So this is 36. Here the favorable cases to the event F is 6. Okay, and total is 216. So we can find the probability directly. I'm writing the probability of E when F has happened, means probability of E intersection F. Probability of E intersection F. Intersection, we forgot to write the intersection. So E intersection F. E intersection F is only one event, 6, 5, 6, 5, 4. Only 6, 5, 4 is the event which is common in both the events. Here, somewhere here, it will come 6, 5, 4. Only this event is common. 6, 5, 3. Here, 6, 5, 4 will come. Okay. So only one event is common. So 1 by 216, the probability of the event common is 1 by 216, and probability of F is 6 by 216. So 216 will cancel, we get 1 by 6. That's solved. So we got the answer. Okay, understood? Mother, father, son line up at a random for a family picture. Okay. So sample is, what will be the sample space if they are lining up in the same line? So the sample space, this is question number 9. M can stand, then F, then S. M stands for mother, F for father, and S for son. So M, F, S, or M, S, F, or F, M, S, or F, S, M, or S, M, F, or S, FM. These are the possible cases. 2 to the 4, 2 the 3. No, sorry. Here, no, that formula will not apply. So 1, 2, 3, 4, 5, 6. Okay. So 6 permutation can be applied. 3p3, yes, 3p3, 3% can be placed in 3 lines. 3p3, 3 into 2, 3 to the 6. So there are possible cases. There are 6 possible cases, equally likely events. NS is equal to 6. Now event E, where sun on one end. S is one end. Where is S1 on one end? Sun is on one end, right side. Here also one end. Here also one end. Here also one end. There are 4 cases when the sun is on one end. Okay. So these are the cases. M, F, F, M, FM, S, M, F, and S, F, M. Okay. Then F is in the middle. F. This case M, F, S. Then this one second. There are 2 cases only. Yes. S, F, M. So these are the only 2 cases when F is in the middle position. Now find the probability of E. Yes, E intersection F. You can find E intersection F first. So E intersection F is common event is this one. M, F, S. S, F, M is also common. S, F, M. So S, F, M. 2 common events. Now probability of F we have to find, and probability of E intersection. The probability of F is equal to number of favorable outcomes in F is 2. Total number of outcomes are 6. Then probability of E intersection F, again possible outcomes are 2. Total number of outcomes are 6. So this is also coming 1. The probability of E when F has occurred is equal to probability of E intersection F divided by probability of F, that is 2 by 6 divided by 2 by 6, that is equal to 1. So like this, you can try the other questions.